I'm going to be explaining how to do extra problem number 8. So this is the one where a person is walking 26 degrees north of east for 4.63 kilometers. So the problem is asking if she were to walk first north and then east just to arrive at the same location, what would her total distance that she would have walked? So I think of distance. So distance is a scalar, and it's referring to how much ground she covers as opposed to displacement, which is what this problem has already given us. It's how far out of place she came or she traveled. So I like to sketch the problem first. So you have your coordinate axes right here. So it says she traveled 26 degrees north of east. So about that. So that would be 4.63 kilometers, and then theta so here's your coordinate axes. This vector represents the magnitude or the total magnitude of displacement that she traveled at 26 degrees. So what this problem is asking is, what if she, instead of going this way to find like the displacement or resultant, what if she walked first north, then east to arrive at her same location? So this is her north component, and then this is her east component. So just visualizing this is basically showing that if she were walking north plus if she were walking east, then she's walking, if you use like tip to tail vector addition in order to solve that, you can see that the resultant would be here when you're using tip to tail. So it'd be like that, and then that is this 4.63. So the way to find these components the way to find the distance is to break the vector up into its components. So this is a displacement vector, and this is the east, and this is the north. I'm just going to use E and N. So east, so the way these things are derived, so east, you can think of this as a right triangle, and because you already have theta is 26 degrees, you can use SOHCAHTOA and remember that cosine is adjacent over hypotenuse, so it would be east. So east over 4.63, which is hypotenuse, equals cosine of 26.0 degrees. And that's how you find the x component or the east component in this place. So E equals, so if you're doing some basic algebra, just do 4.63 cosine 26 degrees, and that would get you 4.1614 kilometers. Then, in order to find the north component, you can think of it again with the right triangle, but this time you're using the sine function because it's the opposite coordinate or the opposite direction over the hypotenuse. So it would be north over 4.63, or the hypotenuse, equals sine of 26 degrees. So if you're using algebra again, you can just do 4.63, the hypotenuse, times sine of 26 degrees, and that would be 2.0296 kilometers. So now we have her north component and we have her east component. We're showing the distance that she traveled. So she's literally going east and then she's going north. So this is her distance or the ground she covered. So you're literally just adding them up to find the total distance because we have the first two distances. So 4.1614 plus 2.0296 equals 6.19107, and then if you're doing total sig figs, you're doing 6.19 kilometers. So that's the total distance that she traveled. So there's the full